So when we're finding domain and stuff from an equation, we can't have a denominator that equals 0, so we look out for fractions. We cannot square root negative numbers, so we look for square root functions. And third, we look for log functions. You cannot take the log of a number less than or equal to 0. So 0 and numbers less than that are problems with logs. Now that one's the least common. What we're going to see more is questions like 1 and 2. But knowing the parent function of what you're looking at will help, because it can kind of just, without even knowing what the specific graph looks like, it can give you a general idea of the graph. So like, for example, number 1. Some of these I would be doing without my calculator because I would expect you to know a little bit about the parent function. For example, we just spent an entire unit talking about things like this. What kind of equations are those, or what would we call the parent function? We know this is a quadratic. Okay? I know enough about this quadratic, maybe not to find the range, but to find the domain. Okay, what's the a value out front tells us which way does this quadratic open? Up. So it really doesn't matter what the graph looks like, it just tells me that it's going to look something like that. And it doesn't really matter if you know where the vertex is or any of that to find the domain, does it? Because if I follow that graph all the way to the left, what does that tell me about my domain? Where is that going to start? Negative infinity. If I follow that all the way to the right, where does my graph stop? Positive infinity. So domain, you should be able to think of a small mental picture of this and kind of figure out what the domain looks like. One hint for you, like on quadratics, the domain is always negative infinity to infinity. That's never going to change for a quadratic. So as soon as you recognize that parent function of that graph, you know what that's going to be. Same as linear. Linear is always going to be negative infinity to infinity. Now, x-intercepts on this, you might have to do a little bit of work for that, but we just did this last chapter. X-intercepts are known as our solutions or our roots. We talked about 5 different ways to find them. One was graph. That's our least efficient way. Where else could we get our x-intercepts? Or how else? Could I use quadratic formula? Yeah. On that quadratic right there, I could use quadratic formula and find my x-intercepts. Could I use completing the square? I couldn't use square roots on this one. What's probably the easiest way to solve this one? The only method I haven't mentioned yet. Factoring. So let's practice our factoring real quick with that. If you want to find your x-intercepts, you can factor this quadratic. Okay, if it's 5x squared and it ends with a -1, that tells me I have one of each sign. And what's going to go first in my parentheses? 5x and x. And then what options do I have for -1? 1 and 1. So then I just check. 5 times -1 is -5x. This is going to add up to -4x, not positive, which means what do I have to do? Switch my signs. So real quick on that, all I have to do is switch this to positive, this to negative, and then to find my x-intercepts, what do I do with that? Set them equal to 0. So that means what are my x-intercepts here? 1 over 5 and -1. The y-intercept, you shouldn't have to do any work at all. You need to remember a y-intercept happens when x equals 0. So if you forget, you can always plug in x equals 0, but what part of the quadratic is my y-intercept? C, the constant term. So what is my y-intercept? 0, -1. So without using a calculator, I can find all of that information about that. Okay? Most of these we will not use a calculator on. Now let's talk about a restricted one, too. How do I know, first off, that this is restricted? It's a fraction. That's one of my lists. Okay, so that's something I got to watch out for. What part of the fraction am I worried about? The denominator. I don't care about the top at all. What I care about is that this cannot equal what? 0. So if I want to know what the problem number is, I do the wrong thing and I set it equal to 0. It can't equal that, so I need to figure out what makes it equal that. So So if I set the bottom equal to 0 and solve it, that's pretty easy for me to solve. What do I get? 5. That tells me x cannot equal 5. So we've already written domains where we avoid one number. If this is the only number I have to avoid in my domain, how can I write it? Where does it start? Negative infinity. Follow it along till we get to the problem number, which is what? 5. To show that I'm skipping over 5, how do I write that? With a parentheses, and then I do a U, and I pick it back up at 5 and go out to where? Infinity. So all you're saying there is I'm skipping over the problem number 5. That's all you have to do to avoid the problem on questions that have fractions. To have x-intercepts on these, the general rule of thumb for x-intercepts is what has to equal 0? Y has to equal 0, which is essentially the entire function. So if I want to find the x-intercept for this, you set the entire function equal to 0. Now, there's a trick to this. If the whole thing has to equal 0 on a fraction, what part of the fraction actually has to equal 0? The top. Why is it the top? Because 0 over anything is what? 0. 0 on the bottom is a whole separate issue. But I'm going to ignore the denominator completely on this and just worry about the top. If I set the top equal to 0 and solve it for x, how do I solve that for x? Divide by 3. That just gives me x is what? 0. That's my x-intercept. So on fractions, really, you just have to set the top equal to 0. What do we say was our rule of thumb for y-intercepts? What has to equal 0? X. So if x has to equal 0, and I don't know how to find the y-intercept on this, what can I do with x equals 0? Just plug it in, right? If I plug it into that equation, that's going to be 3 times 0 over 0 minus 5. What's that give me on top? 0 over negative 5, which just gives me what for my y-intercept? 0. That should make sense. If our x-intercept is 0, our y-intercept should also be 0. That's always how that happens. So you can write your y-intercept as 0, 0. So our general rule of thumb for your x-intercept is that your y has to equal 0. Your general rule of thumb for your y-intercept is that your x has to equal 0. Okay? Any questions on that one with the restriction? Yeah.
On x-intercepts, do you want us to write it like...
You can write it just as x equals. You don't have to write it as a point.
So for y-intercepts, do we have to...
Y-intercepts, we typically write them as points. Yeah. All right, on question 3. First off, it's a square root function. That's your parent function. So that already tells you, because of our list of problems that we talked about at the top, that it's going to have a restricted domain. What did we say for square root functions? You can't take the square root of what kind of number? Negative numbers. So again, you kind of do the opposite of that and do the wrong thing to figure out where the problem is. If I can't take the square root of negative numbers, I take what's under the square root and I set that. It has to be greater than or equal to 0, right? So this is going to tell me my x's, what they have to be. So for that, if I was just solving and I'm ignoring the square root right now, I'm just setting what's underneath greater than or equal to 0. If I solve that for x, what's that going to give me? X is what? Greater than or equal to what? Negative 4. In other words, if I plug in negative 4 to that, it's going to give me 0. That's okay. If I plug in a number lower than negative 4, it's going to give me a negative number, which is not okay. So essentially, we have just said now our x's must be greater than or equal to negative 4. How do we write that as a domain? On the low end, we start at what number? Negative 4 with what kind of symbol? Bracket. If it's greater than or equal to negative 4, it means negative 4 and higher, or out to where? Infinity. So you have to do a little bit of work to figure out what's the problem kind of numbers. So you can set for square roots what's under the square root greater than or equal to 0. x-intercepts. What's our rule of thumb? Your whole equation has to equal what? Whole equation has to equal 0. And then you solve it. How do I solve this square root equation? To get rid of the square root, I square both sides. That doesn't really matter because squaring 0 just gives me 0. And then I solve it for x by subtracting 4. So that tells me it crosses the x-axis at what number? -4. For y-intercepts, what do we do to find those? X equals 0, which means I plug it in. So if I plug in 0 for x, simplify under the square root first, that's going to give me the square root of 4, which is what number for my y-intercept? 0, 2. Questions on that? On the back, we're doing a little bit of function notation work. Just as a review, if I do f of 2, we talked about this with the graphs. This is giving me a what value? X value. If that's giving me an X value and I have an equation instead of a graph, what do I do with that X value? Plug it in, okay? So that should be 2 squared minus 2 times 2. What's this going to give me? 0. Okay? What I would like for you to do, if you can, is at your tables, try B through F. We'll talk about G together and the rest of them, but for now, B. So as you're checking your answers, are there any of those 6 we need to talk about in more depth together? I want to just point out the difference between D and E. D, there's a negative out front, so you're just distributing a negative to your equation, which just switches the signs. E, you're plugging in a negative x and seeing what you get back out. So then if we talk about G, if you didn't know this, okay, first off, hopefully we know you're not like allowed to distribute an F to both of those, which is kind of what they're doing in that. If you didn't know the answer for G, what could you do to figure out if those were the same? You could plug them in. Essentially, we've done most of the work for that. We already know this right here, right? Because we just found that answer. F of x plus 2 gave me what? X squared plus 2x. We got that answer in part F. So we got the answer to the left-hand side. The right-hand side is saying f of x, which was what? X squared minus 2x. That's the original function. Plus f of 2. We already have that as well. What was that? 0. So does that work out to the same thing? No. So if you didn't know the answer, you can always plug it in, see if it works. All right, and let's do one more of these problem functions before talking about piecewise briefly. 5 is a problem function. Why do we know it's a problem function?
Fraction.
It's a fraction. As soon as you see that fraction, you know it's a problem. We should remember with fractions, we cannot have what? 0 on the bottom. So I immediately do the wrong thing and set the bottom equal to 0 and see what that's going to give me. That means my problem number for this is what? -2. So if I want to write my domain then, skipping that problem number, how's that going to look? -infinity to -2, union, pick up at -2, go to infinity. Okay? If I want to know what is f of -1, what do I have to do? Plug in -1 to your equation, right? Because they're giving me an x value. So I take my original equation, anywhere I see an x, I plug it in. That gives me -4 on top, 1 on bottom, which means what's my answer to that? -4. If they want to know what point that is, they are just asking you to write your information as an ordered pair. What did we plug in? X was -1. We got back out what? -4. C, if we want to know where does f of x equal 2, what are they giving me there? A y value. So if I want to know that, how do I set that up? Set your equation equal to 2. Half the battle on these is knowing where to put the number they give you. If it's an x, you plug it in. If it's a y, it's your answer, and you solve it. How do I solve something like this? You can cross multiply. How do I cross multiply when I have a whole number over there? Put it over 1. Good. So if I cross multiply in this one, 1 times x minus 3 is just x minus 3. 2 distributed to x plus 2 gives me 2x plus what? 4. And then we solve. Okay. So if I solve that, I'm going to move the x to the right, and I'm going to move the 4 to the left. That's going to tell me x is equal to what? -7. So what's the ordered pair in this one then? What would go first? -7 would go first, followed by 2. In part D, if I want to know, is that point on the graph, what's the best way to find that without a calculator? What can I do with the x value? Plug it in. If it's on the graph, what's going to happen? I'm going to get that y value back out. Take a minute and try that on your paper, and then we'll move on from there. All right, so once you've checked those, let's talk F and G real quickly. If I want to do part F, what are they asking me to plug in for x? -x, top and bottom. So if I plug in a -x on top, does that really change anything? I mean, is there anything you have to simplify? It changes it, but is there anything I have to simplify? No. Some of these get us because it's like, well, what was I supposed to do there? My goal in that question is that you know what that question is asking you to do, which is take out the x and plug in -x. There's not a whole lot of math work to that. But sometimes I just want you to know what to do, even if there's not a whole lot of multiplying and all of that. Does that make sense? G, what I really, in those two questions, want you to know the difference between the two. F, you're plugging in a -x. G, what are we doing? Distributing a negative. Now here's the trick when you distribute a negative to a fraction. Where do I distribute it typically? Do I distribute it to both top and bottom? Just the top. Why? What is that negative really? What number? It's a -1. So I make it -1 over 1. Does that mean the bottom changes at all? No. This one I'll throw on there just because I want to know what you know about fractions on that one. A lot of people will distribute the negative top and bottom. If you do it top and bottom, it's really distributing -1 twice, which is 1, and that's doing the wrong thing. So your answer for this should just change the top and not the bottom. Could I distribute it to the bottom and not the top? Sure. Both of them are distributing -1 once. I don't care which one you do. Just to be consistent, I usually say just do the top so that you don't mess with your own mind. Okay? Any issues with that? All right, on the way past our homework, we're going to mark it off. On page 146 and 147. We skip around a little bit on this one. We are doing 5 through 7. So 5, 6, 7 on more about functions. No, for homework. We're just going to mark it off now. So on this page, part of your homework is 5 through 7 and 9 through 11. Okay. If you will flip over then to page 153, we will end with piecewise functions, which are all of our favorites. 153. Piecewise functions typically will be on your calculator, mostly because on these kind of things, if you have a calculator, most of us, including me, would say, why would you do this by hand? You can. It's possible. It ain't pretty. But you know what? It's there. I'm going to do one by hand just to show you one, and then we'll show how to do these on the calculator. Sound good? All right. We're only doing 2 examples of these because once you get one, you're pretty good. All right, so piecewise functions are similar to those big graphs we were looking at. Those were all considered piecewise functions. They have little different chunks of different graphs. But how you read them really matters. So for example, the first section is usually the section to the left here. So when I look at this one right here, this is going to be my first section that I graph. Okay, x squared, we should know what x squared looks like. That looked like the parent function for the quadratic, right? If I was to just graph that, where would I start graphing that? 0, 0, because that's the what? The origin, the vertex of it, right? What other points do I have on that quadratic? And if I was doing this now on your papers, don't write all of these points unless you're using a pencil, because I'm going to show you how to graph this and then just erase chunks of it. So if you're doing it in pen, you can either just watch or you can go from there, okay? What other points on this would I have? Over 1, up 1 on either side. Over 2, up 4. Okay, I don't always do it this way, but for some of us that have trouble with the restrictions on these, you may graph the whole thing and then erase pieces of it. That's one way to do this. So if I graphed the entire quadratic, it would look like this. So sometimes I start that way, and then I worry about the restrictions. The restriction says this, I only want the parts of this graph where x is less than 1. Okay, so where is 1 on this graph for x? It's right here, right? That's 1. So if I drew that vertical line right there, that means they only want me to graph the part of that quadratic that is to which side of that line? The left, right? Because it's less than. So if I was doing this on my own paper and I did it in pencil, I would just take an eraser and I would erase that part of the graph right there. I have to fix one other thing on this, and it involves the restriction. When it says x is less than 1 and not equal to, what is it indicating for me? It indicates that it starts right here at 1 with an open circle. So when I do my erasing, I erase that dot right there as well. And I finish it up with an open dot right there. Does that make a little bit of sense how we graph that? If I was doing it by hand, I typically do things that way. I can, at this point, see that restriction and just kind of stop graphing my quadratic at 1. But for those of us that are new at this, it's a little bit difficult. Let's graph the second one. I'm going to color code these things. Second one is the middle section. This one, if you're very, very careful with it, it's very easy. First off, if it was just an equation y equals 3, because that's what f of x is, right? It's y equals. What kind of equation is y equals 3? Or what does it look like on a graph? Horizontal line. However, if I look very carefully before I graph the whole horizontal line, what does the restriction to this say? It's just for x equals 1. So if they're giving me a horizontal line for one x value only, what are they actually giving me there? 1 point. So they're telling me at x equals 1, I have a closed dot at what value? 1, 3. That is it. Now that one in particular, that you need to know what that looks like, whether you're using a calculator or not. When we graph one of these on our calculator, if you have a section that looks like this, that is a point, your calculator does not show it. It cannot, technology only takes us so far. It can't graph just a point. They just don't do it. It is not even on there at all. The other things that you're going to have to know are the open dot, closed dot from the restrictions, because your calculator doesn't graph open dots. So when we graph number 2, we'll talk about what the restrictions look like, and we will know how to graph those from your calculator. Okay. The third equation that we have here, First, it's just helpful to know what kind of equation is this. That's a linear equation. How do we graph a linear equation? We start by graphing its what? Y-intercept. What's its y-intercept? 6. So I start by graphing its 6, and it has a slope of what? -1. So I count down 1 over 1, down 1 over 1, till I graph my line. Okay, and remember, we can erase sections of this in just a second. Okay, so if I graph the entire line, I'm going to go back to the restriction now and see what I need to erase. This one is restricted to x is greater than 1. So that means it wants me to erase the section that is where? To the left of 1. So I'm going to very carefully erase this section that is to the left of 1. It also, because it's simply greater than 1, wants it to start with what? An open circle at 1. It can't have 2 closed dots there. We have that closed dot in the middle. All right? So that's how I would do one of those by hand. That is about as difficult as I would make you do by hand as well, because you know those basic graphs without a calculator. We should know how to graph a line without a calculator. The quadratic wasn't even a very difficult one to graph. More likely something like that will show up in a bonus. So the better you get at those, the better the bonuses are. Okay? Real quick domain and range on this. If I follow the leftmost section, where's my domain going to start? -infinity. Do I have to skip that value in the middle where they all kind of come together? No. Why? Because it has a closed dot along with an open dot, so that makes up for it. So that means, what's my domain actually going to be here? -infinity to +infinity. Strangely enough. Range is bottom to top. What's the lowest y value going to be? -infinity, because of that line that keeps going. What's the highest y value going to be? +infinity, because of the quadratic that keeps going up. Okay? Now, we're going to practice doing one of these on our calculators. So everyone grab your calculator and go to the graphing mode. Any graphing mode on this. You shouldn't have to open a new document. If you go to the Scratchpad, you can get a graph from there. But I'm going to just pull up my calculator so I can show you how to type these in. We're going to go to that same templates menu where we found the matrices. Remember that one just to the right of the number 9? There's this little templates menu. Of course, this is going to give me an error. Excellent. All right, but you use that templates menu. I'll find mine under my menu here. The templates menu is just to the right of the number 9. You can use that. No, not that. Where's mine going to be? I'll figure it out. All right. Of course, this doesn't work for me. All right, so once you have the graph that looks like this, we do our domain. If you follow it out to the left, your domain should start at -infinity. Do I have to skip any values in this? No, because we have closed dots that make up for open dots, so it goes out to infinity. Range on this one, where's the lowest it gets for your y value? 0. So I start with 0 with a bracket, go out to infinity. Good. Issues with piecewise? All right, homework for that is on 155. We are doing questions 1 through 4. 1 through 4. If I were you, I would try to do 1 and 2 without a calculator and do 3 and 4 with. I'm not saying you have to, I'm just saying I would give it a try. 1 is very easy if you actually try to graph it. So.